Recently I used ChatGPT to help me kick off some reverse engineering and vulnerability analysis. This will be useful if you are new to reverse engineering and vulnerability analysis. So for this project, I opened a binary and basically just asked ChatGPT to help me find potentially vulnerable functions. So first I asked it for help looking for vulnerabilities. It said, as an AI language model, it can provide me with general guidance, but ChatGPT is not the thing that will allow me to upload a binary to ChatGPT and it'll just automatically sort of magically find vulnerabilities and spit them out to me. But here's a few of the things it recommends: doing reverse engineering using something like IDA Pro, doing static analysis, again using IDA Pro once the binary is disassembled, using dynamic analysis, so running the program through a fuzzer or a tracer to find interesting functions. And then after that's been done, we can look for common vulnerabilities such as buffer overflows and format string vulnerabilities, etc. Then we move on to the exploitation phase. So in this example, my IDA Pro disassembly had a large number of functions, about 900 functions used in the binary overall. And so I picked one that I knew was vulnerable, strncopy. So I asked it, is strncopy a vulnerable function? And it gives some details about string copy here. So one potential vulnerability with string copy is it does not automatically add a null terminator to the destination string, which is hex 00. If you don't add a null terminator, this can result in a buffer overflow vulnerability where data is just copied until it overflows the buffer. To avoid this vulnerability, it is recommended to always use a buffer size that is large enough to hold the entire input string plus the null terminator. Alternatively, you can use safer string functions like string copy s or strl copy, which automatically add the null terminator. So this is valid and useful information. Next, we ask for an example of code that uses string copy that is vulnerable to a buffer overflow. In this example, they give us some C source code here, which we could compile and run that source code to trigger a buffer overflow. The useful thing about that is that we would then be able to disassemble that compiled binary in IDA Pro or your disassembler of choice, and then see if there are any interesting features of the disassembled binary when we're looking at sort of like the raw assembly and the flow graphs. This will help us sort of get familiar with vulnerability patterns. And then it describes the issue here. In this example, the source, which is a 100 byte buffer, is copied into the destination, which is only a 10 byte buffer, and so there's a massive buffer overflow here. And then I asked ChatGPT to fix the vulnerability for me. So it created this example vulnerable code, and then I asked it to patch the vulnerable code. And so here it has the source and destination buffers. Source is 100 bytes, destination is 101 bytes, which takes into account the appending of the null byte at the end. Great. So it fixes its own vulnerable code. And then upon looking through the rest of the code, we find another potentially vulnerable function, asking how would the string compare function be vulnerable. And so in this example, it says that one potential vulnerability with string compare is that it compares strings based on their null terminated contents. If the strings being compared are not null terminated, or if the length of the string is not properly checked before calling string compare, buffer overflow can occur. So again, gives us some example code in C. And in this example, the S1 and S2 variable strings are not null terminated. And so calling string compare on this would result in potentially a buffer overflow or crashing, just some undefined functionality. And then it gives us some other examples here. And then when I'm looking at my binary, I asked if I could give it a list of potentially unsafe functions. And so it says, sure, it doesn't quite understand this here. It's starting to give me some of its own recommendations on things to look for, which is Actually super useful, but that's not exactly what I wanted. So here it has about 14 functions that it recommends us not using or checking in code. So if we find these, we should be concerned. But what I was really asking was, I wanted to get a list of, out of all of these functions, which are in my binary itself, so large number of functions, there's over 900 functions in total, can you direct my attention to functions that might be vulnerable? And so here it responds, yes, I can do that for you. Here are a number of potential issues. Here are the functions out of that list that can potentially cause problems. So there's a lot, and there's a lot that I actually have not looked at before. So we'll dive into some of these and see what the particular issues with some of these might be. When I did a check, out of the 900 or so functions, it recommended checking about 100 or so, which is a lot, but there's, again, about 800 that we don't have to worry about. So one of the ones that I picked to ask ChatGPT some more information about is the last one here, is what can go wrong with the create waitable timer W function. It says this creates a waitable timer object which can be used to synchronize multiple threads or processes. However, if used incorrectly, this function can cause problems or be vulnerable in several ways, including deadlocks, resource leaks, security vulnerabilities. So this is interesting here. If the security attributes parameter is not set correctly, the timer object can be accessed by unauthorized users, leading to security vulnerabilities. Interesting. And then to prevent these issues, it's important to use this function carefully and correctly. Then I need to ask it to review the remainder of the functions in my binary. Here's a long list of the rest of the functions. So now I've covered all the functions in my binary. It's saying it's impossible to determine if any of these are actually vulnerable, but these are some of the functions that you want to look at. And again, here's the list. It's filtering out about a third to a sixth of them. It's saying here are the ones that you want to check. And I ask it for some additional explanation here. It's not going into detail, so then I have to ask again specifically about a vulnerability. And so here I have to ask about how a specific function might be vulnerable. How could heap free be vulnerable? In this case, it's saying it could be a component in a use after free vulnerability or a double free attack if heap free is called multiple times in the flow of a binary. In case you're new to vulnerability analysis, you can ask ChatGPT, how would I identify this type of vulnerability? And so here it's suggesting that you look for situations where memory is freed more than once, such as a pointer is freed twice without being allocated again in between the frees. A pointer is freed, then reallocated, and then freed again without any intervening memory allocations. Those are all double frees, and it is possible to find those with static analysis. And then for the sake of my own knowledge, I ask about the disconnect named pipe function. That is one of the functions that ChatGPT lists as being potentially vulnerable. I haven't seen that before, so I asked for some more details. And it says that a vulnerability can arise if attacker is able to gain control of the name pipe's server end before it is disconnected. If an attacker is able to manipulate the name pipe's server end before disconnecting it, they can potentially cause the server process to execute malicious code or crash. For example, an attacker could overwrite the memory pointed to by the LP bytes read parameter with a controlled value that points to a malicious payload. So this would be, you put your malicious payload in memory, you override a pointer that's pointed to by this LP bytes read parameter, and then instead of the legitimate code being contained in that LP bytes read parameter, you've overwritten that pointer and it's pointing to malicious code. I'm assuming that the pointer will then be executed at some point during the function call. Another potential issue is the disconnect name pipe function is not properly called, either to a coding error or due to an attacker bypassing the function call. This can lead to a denial of service, where the name pipe remains open and unavailable for use. So we have two potential issues. So we've got remote code execution vulnerability and a denial of service vulnerability. And then we ask it for example code. And in this example code, it's also showing us that it's possible to trigger a double free memory bug. So in this example, we're creating a named pipe, and then after some stuff happens, we call disconnect name pipe twice. So here it's disconnected again for some reason. So we're actually, during the disconnection, I'm assuming that there's a call to something like heap free. So really the root cause of this is related to the previous vulnerable function that we looked at, where we're freeing memory from the heap, and then we try to free the same memory that's already been freed off the heap. So it says in this example, disconnect name pipe function is called twice on the same pipe handle, which can cause a double free. This can occur if the function is called more than once, potentially leading to crashes. So there you have it. That was a quick review of what you can do to get spun up on reverse engineering for vulnerability discovery. All we've needed to do so far is drop our binary into a disassembler. In my case, I used IDA Pro, but you can use Ghidra or your disassembler of choice. And then hand the list of functions over to ChatGPT and ask ChatGPT for guidance on which functions to focus on discovering vulnerabilities for. Then once we've gotten some guidance from ChatGPT, we can actually ask it to explain to us the root cause of some of these functions being vulnerable, so we can look for examples of that either in code or in the disassembly. So I hope this brief video has inspired you to start incorporating ChatGPT into your vulnerability analysis or reverse engineering flows. For me, there's a couple functions that I haven't seen examples of before, and I think it would be interesting to create a proof of concept, an example like this, create a proof of concept, and then actually exploit it or cause a crash to see how that might be done in the real world.